All right, let's get started. So hi everyone, welcome to DSCI 511. This is your Python programming for data science course. I'm very excited to see you all here in the lecture today and in the upcoming lectures during this course and other courses. So my name is Arman. I'm in charge of 4 of your courses in this year's MDS program. This one, 511, Python programming. Next one is 512, algorithms and data structures. The one after that is 513, databases and data retrieval. And the last one that I'll teach is the supervised learning 2, which is about deep learning. Okay, so before getting started, it's always good to know your audience. I want to ask you who in this room has done programming in the past for anything besides a programming course? By show of hands. Okay, so there's a lot of good experience here. All right, what about writing Python code in the past? Who has written any Python code? Okay, so you're pretty familiar with Python here as well. Okay, so that helps me adjust a little bit here, my content. Okay, so about the course itself. So in this course, we are going to be talking about various topics, starting from the basics, learning about data types that are used in Python, if-else conditions, and also a bunch of other basic stuff like printing things to the output, and so on and so forth. We're also going to learn about loops and functions, and then a little bit about unit testing and about an important topic of classes in Lecture 3. And then a bit about style guides, scripts, and imports. And at that point, we wrap up talking about fundamentals of Python. And then afterwards, this was the first 4 lectures. For the next 4 lectures, or the last 4 lectures of the course, we dedicate the lectures to introducing you to important packages that are used in Python, namely NumPy, which is for matrix computations, and also Pandas, which is one of the most famous packages for basically working with data. So this is the overall scheme of the course. Now, I haven't yet pushed the lecture notes for this lecture and the next one to the repo, but I'll do that after the lecture today. I haven't also yet published the assignment. Again, that's something I'll do in the afternoon, so don't worry about that. Okay. I'll probably publish the lecture notes before the lectures, usually, but today I'm a little bit behind schedule. That's not unusual, by the way. Okay. All right, so let's jump right into it. So, just like I said, in this course, we're going to be learning about Python. Why Python? Chances are, even if you have never coded in the Python programming language, you have heard about Python at this point. This programming language is one of probably the most commonly used, the most widely used programming language for data science especially. We teach this because of this reason, and the other reason is that this is a general purpose language. Unlike languages like R or MATLAB, this is the language that runs the backends for a lot of websites, a lot of applications that you use on a daily basis, anything from industrial purposes, and so on and so forth. So Python is a very capable language. The one important difference between Python and other programming languages is that Python is an interpreted language. The meaning of this, so let me just write down the word here. The meaning of this is in other programming languages, lower level programming languages, that you write code that is typically closer to machine code, like zeros and ones or very basic instructions. Examples of such programming languages like C, C++, Fortran. For those kind of languages, you have a program called the compiler, which translates the code that you write directly to zeros and ones, basically to binary, to a format that the computer's CPU and memory can understand. With Python, it's a little bit different. You don't talk directly to the operating system and to the hardware. You talk to an interpreter. And this is similar to a situation that you want to talk to a person whose language you don't know. So you talk to an interpreter, that person translates whatever you say to that person, and then the other person talks to this interpreter, and they translate whatever that person has said back to you. So this process, instead of directly talking to the person, this takes like a lot longer. So the process becomes much slower, right? So this is a distinction between Python and other languages that you might be familiar with. The programming language itself is slow in its execution time, but it's very, very flexible. And this is why this is so widely used. So if you have an idea, you want to express it in code, you can very, very quickly do that. Other languages, lower level languages like C and C++, Fortran, they do not allow you to do so. You have to have a very good understanding of the computer's memory, of different types of hardware, and like a bunch of stuff that you don't want to know necessarily as a data scientist or as a person who just wants to do some analysis or write a program that does something for that person. So this is, despite being slow, it is very flexible. So why is it the case? Why don't we just from the start learn a language that is fast? There are two reasons for this. First is in today's world, not everything is about the execution time of a code. So you also have to pay developers, data scientists, programmers in order to be able to write a program that does something special for you, right? So that is a cost. And sometimes you want to forego that high speed of execution of the code in order to pay less to the developers, so that you can have a much lower turnaround time for your code, for your development and everything. The other reason is that while the instructions that you write in Python, like pure instructions, are slow, usually what we will be working with is that we work with packages like pandas, like NumPy. And these packages are almost entirely written in C and C++. So you just make calls. You just order some computation to the very fast libraries, and then they do the computations in very fast, very quickly for you, and return the results to you. So it doesn't matter anyway that much. If you're if there's a very strict requirement for the code to run very fast and for it to be super simple and not depend on an interpreter, then yes, you must go to lower level languages like C and ++, like on particular devices or some other applications. Okay, so this was the first thing I wanted to get out of the way. Okay, now that we've learned a little bit about what Python is and a little bit about its features, next thing is, how do we run Python? How do we write a code and execute it using Python? So I'm going to show you a couple of ways in order to do that. I know this is, I think, your third lecture, so you might not have yet learned about Jupyter Notebooks or VS Code that much. So I'm going to just quickly show you how we can fire up an IDE and then start writing code. Okay. Any questions at this point? All right. Okay, so I'm going to show you two ways of running Python code. The first is using VS Code. So you should have VS Code installed on your system by now. So let me open up VS Code here. And then I'm going to load. So you have to open a folder that contains that you want to work in first. So you can do that by Command O, Control O, or opening this file menu and then open folder. And then you open up a folder where you want to work in. Okay, so here, because I already have that folder in my recents. Okay, so this is the folder that contains the courses repo, my version of the repo. Okay, now how can we start writing code? So in order to run Python, you can either do this from the terminal, so that's the first way, or using Jupyter Notebooks. So I'm going to show you both ways of doing this. Okay, so one thing we can do is that if you pull up this thing over here, this pane over here, you can see a terminal window. Okay, and if that doesn't show up, you can also press Command J. And when I say Command, because I'm on a Mac, that usually translates to Control J on other machines. I'm not sure, but that's usually the case. So I'm going to stick to the shortcuts that I have on my Mac because I don't remember shortcuts on other systems, but it should be something similar. If you can't find the shortcut that you're looking for, you can go here, Keyboard Shortcuts. So click on that gear icon and then Keyboard Shortcuts, and that opens up all the shortcuts that you need. Okay, so Command J, let me open up my terminal here, and then you can simply, okay, let me see where I am. Yeah, I'm in the right directory. You can type code, and then type the name of the file that you want to start working with. So Python code can be written in any text-based file. So for example, let me do demo.py. Okay, it opens up an empty file for me, which shows demo.py as the file name, and it also assigns this nice icon, the Python icon, to it, so that it's easier visually to see what kind of file is that. Again, note that this is just a text file, nothing else, and the .py is just the convention. It doesn't do anything to the content of the file. So let me start with a super easy statement, super famous program that you write in any programming language when you start. Oh, I can't spell. Okay, so yeah, type print hello world in double or single quotations, and we'll talk about this print and everything else. This is just for the purpose of demonstration here. Save the file, and the first way that you can run such a Python script or Python code is that in your terminal you type Python and then demo.py, and then if you run that, hopefully you'll get back a result. So this is the result of passing that text file that contains the code to the Python interpreter. And the Python interpreter just takes the responsibility of translating it to machine code for you, runs the program in the terminal, and then returns back to you the results. Okay, so that's one way. But this might not be a very convenient way, especially when you're working on data science projects. Because typically you want to, for example, create plots and graphs, do analysis, and also write down something so that other people can understand what you have done. So you kind of want to build a narrative for your analysis. Because at this stage, for people like us who do data science, they're not necessarily very concerned about production code, like the code that goes into applications and is exposed to the public so that they can use their applications like YouTube, Instagram, whatever. We're usually concerned with doing analysis. And when we're doing analysis, it's not very important for us to keep everything in like .py scripts so that we can run it in a terminal on a server. Okay? If it comes to that, if you want to package everything together, all your code, and then run it on a server, you typically have access to a terminal, and then you want to be able to quickly run that code on that server, right? You don't have a GUI or everything or anything like that. Okay, so that's one way. Let me show you the other way, and I'm going to show you these different ways so that we can get started with the lecture material soon. Okay, any questions about the text file environment and running code from terminal? Okay. Now, the other way to run Python code, yeah, sure.
So obviously, if you want to run from a certain directory, you can just change directory to that directory. If you're not in that directory, can you do like code, type the full path and then the file name, and it'll just without doing CD, it will go there?
Yeah. Yeah, okay, so the question is, if we're not in the directory which contains our Python file, if we're in like another directory, in our home directory or wherever we are, can we type just Python and then followed by the full path of the file? And the answer is yes, because that basically points to the file that you want to feed to the Python interpreter. Okay. Yeah, that would be Python demo.py. So we want to run the demo.py file. Okay. All right. So the other way, the more could be more interesting way to write Python code. So I'm going to just close this file here. Reset my terminal. You can create a file with this extension. So code, let me call it or scratch. Okay, scratch.ipynb, and the .ipynb stands for IPython notebook. Okay, so this creates a notebook file for us. What is a notebook file? A notebook file is, if you open it up like in a regular text editor, you'll see basically some kind of a structure that is already put there. And this is an environment that you can place code along with text or graphs and anything all put together in one place. So this notebook file is internally connected to a Python interpreter. Okay? And whenever you have a code cell, something like this that we have here, so if I type print, hello, world. Okay, so this is a code cell, and you can see that it says Python over here. And if I run this piece of code, the Jupyter Notebook is going to send this code to the Python interpreter, run it for us, and then return the results back to us in the same notebook file. Okay, and one other thing is that here we can also write text. Hi, my name is Arman. Okay. And then here we also have text, we also have code, and you can immediately see how much easier it is for us to follow somebody else's work. And this is the format in which the lecture notes are usually provided to you in MDS. So, okay, so now if I type code in a code cell, these are called cells. Okay, this is a markdown cell, meaning there's just formatted text, and this is a code cell, and you can run this code cell either by clicking this play button over here, or the way that I like to run it is by pressing Control-Enter. So when you do Control-Enter, okay, so this is very important. I don't think you have yet been introduced to environments, like Conda environments, like in 5.2.1? Not yet. Okay, not yet. Mm-hmm. Okay. Right. Yeah, but eventually you're going to learn how to use these Conda environments, which basically is that you have a separate computational environment for different courses. For example, if you install different packages, different versions of Python and stuff like that. Here, just for convenience, I have a separate environment for this course, but you don't have to. You don't have to do this just yet. Okay, so this is why I'm seeing this message. You can disregard that. Here I have my environment, DSCI 511, just so you know. You can also change the environment by clicking this icon over here. And as soon as I've done that, you can see that my code runs here. We can clear all outputs and run it again so that you can see that the output appears right below that. And we can also create other code cells as well when you're in selection mode, meaning that you're not here. This is edit mode, that you can type stuff. Selection mode is that when you press escape and then you can't type, but you can, if you press keys on your keyboard, it's going to do some certain operations for you. For example, you can create a new cell below by pressing B, and that creates a new code cell for you. And again, I can do something else here. For example, yeah. Okay, and then you run that. And this time I pressed Shift-Enter. The difference between Shift-Enter and Control-Enter is that it advances to the next cell. If this next cell doesn't exist, it creates a new one for you. Okay, so this is the other way to run Python code, and this is what we usually use in this course. Not always, but usually. Okay, so this is the VS Code environment. The VS Code environment is still in development in VS Code, but I start to like it better than Jupyter Lab. The other environment that you can use to run Python code and Jupyter Notebooks particularly is Jupyter Lab. Let me now show you how you can run your code or use your notebooks in Jupyter Lab. In order to do this, so let me just minimize this window. You can open up a terminal, and then let me just navigate to the folder that contains the stuff that I have here. Okay, and okay. So I just changed my working directory. Okay, so from here, if you type either Jupyter Lab or the shorthand for it is JL, and press enter, you can see a bunch of stuff shows up on the screen, and then eventually you're going to see a browser window like this. Let me just, yeah. Okay, so you're going to see something like this. This is Jupyter Lab, an environment for you to work with Jupyter Notebooks and also .py files, script files in general, and also like having terminal windows to do stuff in them. But this is mostly used just for Jupyter Notebooks. So again, the Jupyter Notebook that I created in VS Code, you can see that it shows up here. I can double-click that, and there we go. You can see that my text cells and code cells, everything appears there. And here you also have this button that you can choose the environment that you're interested in. Okay, here I have an environment. You don't have to have one, so that's perfectly okay. And let me clear the output here just in a second. Okay, so now if I click here, Control Enter again. Yeah, hello world, Control Enter. My name is Arman, and there we go. Okay, so this is just a very, very, very brief introduction to these environments. And also note that using the launcher window that you have here, you can also just fire up a terminal window as well, and just work conveniently from the terminal window inside your JupyterLab environment. One thing I wanted to show you that is super helpful when working with JupyterLab is this table of contents option here. Okay, so you can just quickly jump between sections of your notebook. That's super helpful. Okay, and you have your file explorer here. You also have a Git extension, and yeah, a bunch of other things. But just for now, this is, I guess, enough for us to get started. It can also move windows around and do stuff like this in order to work in parallel in two different windows. Okay, any questions? Yeah. The difference between the two? So yeah, okay, so I was just going to talk about that in a moment. So the question is the differences between VS Code and JupyterLab. We call these programs, like JupyterLab and VS Code, we call them IDEs, Integrated Development Environments. And what is the meaning of that like long phrase? It means that integrated development environment means that you have everything in one place. So basically, technically, you can write Python code using a plain text editor. Okay, that's all you're going to need. You write it, you save it, you run it using Python, that's it. But in reality, in order to develop code and in order to work efficiently, you need a lot of other things all in one place in order to be able to quickly get stuff done. So in these environments, you have a file explorer, you have a terminal, you can have multiple windows, you can have variable explorers, you can have debugging environments, you can have like Git extensions, everything in one place. This is why we call them integrated development environments. Okay, and different IDEs have different capabilities. For example, in the world of software engineering, VS Code is much more popular than JupyterLab because it's geared towards basically just writing code, writing scripts, instead of Jupyter Notebooks, which are more geared towards data science projects. And JupyterLab is essentially developed basically for Jupyter Notebooks, and then its capabilities basically extended to other types of documents. So this is you can say that VS Code is a like full-blown IDE with all of probably with everything that you're going to need for software development in general. But JupyterLab is more a tool that data scientists use for their analysis. Okay, it has less functionalities compared to VS Code. Okay. One tiny other difference before jumping into the course material is that in order to open a Jupyter Notebook inside JupyterLab, you have to navigate to that directory, fire up JupyterLab, and then click on the file itself. However, if you have VS Code, you can just go to your file explorer, double-click on your Jupyter Notebook, and it opens up your notebook. Okay, so whether you use JupyterLab or you use VS Code, that's totally up to you. Use the environment that you're more comfortable with. It may not be the case with other courses, but as long as you can get whatever you need to get done, that's fine by me. Okay, so for today, I'm going to use VS Code. So I'm just going to shut down this one and close it and close this terminal window as well. All right. So let me just delete everything here. When you're in selection mode, I hit Control-A to select all the cells, and if you hit D twice, it deletes the cells. Okay, DD, and then it deletes the cells. Okay. All right, so let's get started with the course content itself. So we are going to start with introducing data types in Python. And usually this part of the this part of introducing a programming language could be something pretty boring, because they say, okay, this is the numeric type, this is like text type and everything, and it's not really that interesting. You can understand that and learn that yourself. But what I really want you to have as a take-home message is what we discuss here as the overarching concept over data types. So what are the data types that you know from other programming languages or from Python? Pardon me? Yeah. Yeah, strings, integers, what else? Yeah, tuples or tuple. I tend to pronounce it as tuples. Yeah, tuples and lists and yeah, a bunch of other stuff. Okay, a bunch of other data types. What is a data type? We say integer, float, and string and everything else, but what is it exactly? So a data type is what we call an abstraction. It means that this is a way that we want to model data using that particular data type. For example, when we say that we have a string data type, it means that we have a bunch of characters in sequential order, and then we save it in some place in the memory, and there are some capabilities associated with that particular data type. Same goes for integers. When you have an integer, you know that this means that this data type has a number represented as digits. There are certain operations you can do with that. So that's a way of modeling a number. And strings are a way of modeling text. Is this the only way? No, absolutely not. There are other ways to do these. And for simpler data types like strings and integers and floats, these are usually kind of the same among different programming languages, but there are other more sophisticated data types. For example, like lists, like contain lists of different data types, and dictionaries and all other stuff, which are, again, basically a way of modeling data, a way that you organize your data. But here's a very important thing here. A data type, when you have a variable that contains values of a particular data type, it's not just the values. A very important thing here is that a data type is the values, the data itself, and also the kind of operations that are allowed for that particular data type. This is a very, very important point. And this is kind of the overarching principle that I just noted at. So as we go along with the course, in the upcoming lectures, we are going to talk about the concept of classes. So that's a generalization of the idea of data type. So if we have an integer data type, a string data type, a list, an array, or other things, is it possible for us to also invent our own data types? Yes, it's possible. We'll learn how to do it in lecture 3. So again, the concept of data type is the data itself. Okay, whatever the values are, 1, 2, 3, MDS program, a string, and whatever you're going to save in that particular variable, and also the kind of operations that you can do with that data type. For example, you can add two numbers together, but addition of two strings, if you don't strictly define it, might not mean anything. Or, for example, you have number 5 and 10. Okay, addition of these two numbers makes sense in mathematical terms, but if you just put, for example, 5 and 10 side by side, 510, what does that mean in the world of like math computations? Nothing. So this is an example of associated with certain data types is also certain operations that you can do. And this is, if you generalize this concept, you'll arrive at the notion of objects. So before going too much into the weeds, let me start by introducing the common data types in Python, and as we go along, I'll mention examples of what I was talking about here. Okay, before going into the lecture notes, any questions at this point about data types? So take-home message, the data itself, operations that you can do with that data. Okay, yeah, go ahead. Mm-hmm. Yeah, very, very good point. So what's your name? Yeah, what Nabi is saying here is that the default data types that we have are like default classes that basically come with Python. That's exactly true. So everything in Python is defined, you can say as a data type, but in Python we say it's just defined using classes. Okay? just something to have in your mind, not something to worry about at this point, just so that you've heard it at this point. Okay, so let's start with the basic data types that are available in Python. First of all, when we want to store a value inside the computer's memory, we say that in computer programming terms, we say that we define a variable. For example, we can say x. Is the font too small, the font size? Is it better now? Oh, okay. Yeah. So suppose that we say 45. Okay, x equals 45. We call x a variable. Okay, so that this x variable contains the number 45, which we will see that this is an integer type. So let's see. So the basic types for Python in the Python programming language, we'll start with the integer type, which is just a whole number. If we hit Control Enter, we can see that the code runs successfully. You can see this green check mark over here. And we have a particular function called type. And whenever we have a variable, we can type type of x, to see what the type of this variable is. And as soon as you run that, you can see the type of x is integer. Okay? And don't worry about statements like this, where you have a word followed by open and close parentheses. We will talk about, these are called functions. We will talk about functions in more detail in the next lecture. Just for now, this is a tool that you can use to inspect the type of a variable. Okay, so integers, and between integers, again, this is the data that we have stored. And if you have another integer over here, like 100, then one operation that is allowed between integers is addition, for example. This is, again, we're coming back to this concept. Okay, the data itself, the operations that are allowed. However, for example, it's not possible to just put these two digits together, like we call it concatenation. You cannot concatenate those two numbers. This is not defined for integers. Okay. All right. So integers, the other type of numerical values that we can have are floats, which are floating point numbers. Okay. And that's a number that has a decimal point and then a fractional part. Okay, and if we run that, and again run type x, it says float. Okay. And let me quickly go through these parts. So again, between these numbers, the operations that are defined are basically these operations. So addition, subtraction, multiplication, like the regular stuff that you see everywhere. Okay, it's important to know that the exponentiation is shown with double stars, double asterisks, and the modulo operator, which shows the remainder of division. There is one other operator that we talk about, is called floor division. Okay, and this divides two numbers, like one number by the other one, and rounds down the result. Okay, so this is the data type and the kind of operations that you can do with that data type. Okay. Well, okay, let me define two integers over here. Y equals, let's say 2. Okay, and if we divide x over y, so will the result be just 2 as an integer type or a float? We can find that out, and we can see the type of this is a float by seeing the decimal point, and you can confirm that by running type x over y. So this is a little bit, if you're used to other programming languages, when you divide two integers, you usually get back an integer result. This is different here. So just in order to be on the safe side, whenever you do division, it always returns back a float to you. Okay, now let's see an example of rounding numbers down. So 5 over 3 is this value. However, if you do the floor division, if you really need the decimal part to be rounded down, you can do the floor division like that, and you can see 5 over 3 will become 1. And then again, note that this does rounding down. So rounding down, okay? And if we do this, what is the result that you expect to see? It rounds down. So 5 over 3 was 1.6 something. Minus 2, exactly, because it rounds down. Okay? All right. The other important operator is the modulo operator, which basically just shows the remainder of division. So when you divide 100 by 2, it's perfectly divisible by 2, so you get back 50, and there's no remainder. So the remainder would be 0. Okay, let me get rid of this. And if you run that, the remainder is 0. If you divide 101 by 2, you'll get back 1 because it's not divisible perfectly, and then 102 is again divisible. So this is another important operator. Okay, one last thing about the numerical data type before boring you with all these little details is the order of operations. So this is very, very important. The order of operations in programming terms is always. So let me start with a question. So this computation, 10 by 2 multiplied by 2 minus 3. Okay, what do you think the result of this operation will be? Can you speak up? 39? No. No. 29. Why? We'll see in a second. So the reason is that there are certain priorities for computations when you do a numerical operation. Okay, so for example, whatever is inside parentheses, that will be evaluated first, regardless of anything else. Okay, inside parentheses, you evaluate that first. And then after that, the priority goes to multiplication. And then after that goes to division. And finally, it goes to addition and subtraction. Okay? So this is why here this is minus 1, and this is 5, this is minus 5, and 34 minus 5 is 29. Okay? So whenever you want to basically override that default operations order, you can use open-close parentheses. And never rely on just order of operations. Maybe just for very basic stuff, but use parentheses whenever you can. Okay, so again, these are all. You can find the notes about all of these details that I'm talking about in the lecture notes. So I'm going to push the notes after the lecture. You don't need to take notes. Okay, so this is it about numbers. There is another type that we might encounter. Again, this is not too important. We're going to see instances of this later on. But again, we have a none type. So a none type has only one value, none. So it means the absence of something. Okay? When x is equal to none, that's the only value that this type can provide for you. And if you say type of x, you'll get back the none type. And why is it important? Sometimes when we define functions, the functions do some actions but don't return anything. For example, they just do some operations, but they don't return anything to us. And we're going to talk about these returning and I mean the terminology about functions later on. But when we don't return anything, they basically return the none type. This is like a sign or a clue to the Python interpreter that this function didn't return anything. Okay, so that's the none type. And now, okay, the important data type that the operations over which seems to vary between different programming languages, and that's the string data type. Okay, so before getting started with the string data type, let's take a break of maybe 3 to 4 minutes, and then, yeah, we'll be back in a bit, okay? Okay, let's continue with the lecture. So, a bunch of important stuff. Okay. A bunch of important stuff is coming up, so let's get right to it. Okay, so the other data type that's very important, and you're gonna use that a lot in the lab, is the string data type. So the way that we can basically define a string is that we create a name for our variable, and then I just forgot to tell you that this is the assignment operator, not the equality operator, but because you have had fulfilled a programming prerequisite, I just took it for granted. Okay, so my name equals, and then we can define strings either with double quotation marks or with single quotation marks in Python. There's no difference. We'll get to particular applications of the two later on in the lecture. Okay, so I can say Arman, and then there we go. And if I go ahead and run this like that, it shows me the value of this. We can also say print, and then it removes the quotation marks because the print function interprets whatever it receives. So it receives it as a string, it removes the quotation marks. Okay. Now, the other way to define a string type is if you have like a very long string, you can define it using triple quotes, and you basically can insert like new lines and stuff. So for example, you can say that course description. Yeah, the height of this table is quite different to what I'm used to, so it messes up with my typing. I'm sorry for all of these typos. Okay. Yeah, so for example, we say we can open up triple quotes, okay, something like this, and then close it with triple quotes, and then we can, in between, we can type program design and data, and then we can type overview of data structures, and then we can insert new lines. Hey, here. Okay, so this is a way to define long pieces of text in Python. You'll see this way of defining a string when we write documentation for our functions. So this is the only reason that I'm mentioning this here. So if you run this, and then here we can put course description, and you can see that in VS Code in JupyterLab as well. We get autocomplete, so you don't necessarily need to write out the entire name of the variable. It autocompletes that for you. And we print this, and there we go. And note that if I just take a look at the value of the variable itself, I'll get back something like this. This looks cryptic at this point, but later on I'll tell you what all these /n's and everything is about. Okay? Any questions? Yeah.
Yeah. So the latest version of Python supports typing.
Mm-hmm.
So basically it allows us to specify different types of
Right. Okay, yeah, good question. So in the latest version of Python, there's this concept of type hinting, actually not typing. So this relates to the concept that in lower level languages, basically when you define a variable, you have to, ahead of time, you have to tell what kind of data this variable is going to hold. Okay, so for example, in C, you say int x is equal to 1. It means that variable x is going to be equal to 1, and its data type is integer, and the programming language immediately knows where to put that variable. But in Python, it's super flexible. You don't have to define what type of data you're storing in a variable. It's going to be inferred based on what value you're feeding into that variable. However, there is this concept of type hinting, where you can basically say that this thing that I'm introducing here is of type str, for example. You can do that by doing something like that. However, this does not change anything about the execution of your code. This is just a hint to developers, or if you're using like VS Code and you use str and then you assign like a number to that, it will complain, okay? And yeah, if we run a linter, I have disabled that just so that we don't get as many annoying pop-ups, but it will tell you, hey, you defined it to be a str, but now you're using an integer. Do you think that's right? It doesn't like stop the execution of the program. It's just a hinting. Good question.
So
Yes, yes. So question is, if you want to define a value as a float, you have to add like the decimal point to it. Yes, that's the way that Python interprets that value as a float. Or we're going to learn about type conversions, and I'll tell you that you can apply a function on an integer or on a string, basically, to convert it to a float. Okay. All right. The other important type is the Boolean type. And again, this is something that you are probably familiar with from other programming languages. So a Boolean type stores the values of either true or false. And we're going to need that for checking conditions. And Boolean types, let me say bool1, and then it can hold the value of true. Okay, and that's it. We can inspect the type of it, bool1, and then it says a Boolean operator. So its importance is in the fact that we can do logical comparisons with these Boolean operators. For example, we can do something like this. So the result of logical operations is always a Boolean. So 2 smaller than 3, yeah, that returns true. And if you inspect the type of this expression, it's going to say bool. Okay? So the result of logical operations is always going to be a Boolean. All right. And there are a bunch of Boolean operators or comparison operators. We have equality operator, which perhaps is one of the most important ones. So for example, 2, if you want to check whether 2 is equal to 2, you have to use double equal signs. Okay? So 2 equals to 2, yes, that's true. Okay? And then for greater than, smaller than, that's the symbols that you get. For greater than or smaller, you get this symbol. So the greater than or smaller than comes first, and then the equal sign. And that is basically it. So greater than, smaller than, greater than, equal to, smaller than, equal to, or equal. The one other important operator is the not equal to. Okay? We can prepend the equal sign with an exclamation mark, and that means 2 is not equal to 2, which is obviously false. Okay? So these are the important ones, and the kind of Boolean operations that we're going to do. Okay, so let's do something interesting here. 2 equals to, and let me say 2 as a string. Are these two values equal? No. Oh, yeah, yeah. This is the result of this is true, meaning that those two values are not equal. Okay, so this is a manifestation of different types interacting with each other, and Python basically doesn't know what it means to equate number 2 with a string with character 2 inside of that. Okay. All right, so another type of Boolean operators is when you have a composition of different conditions. For example, you have one condition here and another condition here. You want to check if both of these conditions are true at the same time. For example, 2 smaller than 3, and, that's the keyword that we use, and 3 smaller than 5, okay? And that's true. Okay, so it checks both conditions. If both are true, it returns true. And we can do these like a practice with these. So true by itself, because the result of a comparison is a Boolean, and we can use the Boolean itself, true or false. What is the result of this one? Yeah, exactly, it's true, because one side of the or is true, so it says either if this one is true or the other one is true. Okay, so we have and, we have or, and then we have not. Okay? So again, not just negates condition. Okay? All right, so that's about it for Booleans. Now let's move on to casting or conversion. So what if we have a scenario over here, for example, we receive input from the user, for example. When we receive input from the user, what we receive is always going to be a string. So basically just some characters. And we want to do some operations with that. So for example, let's suppose that I have received this expression of this mathematical expression, 32, okay? And I have b over here equals to 100, and I want to add a to b, and it gives me a type error, okay? It says that can only concatenate stir, not int to stir. So it kind of looks for concatenation because one side is a string. It wants to just clump them together, but it can't do so. This is, again, an example of like the data types that we talked about, the operations that are allowed. You're not allowed to add a number to a string, okay? So again, this is the strings, the variables, the kind of data, the data that we have stored in them, and the kind of operations that are allowed, which constitute a data type. Okay, so now how can we solve this problem? Basically, we have functions which have the same names as the types themselves that we can use to convert those values. For example, if I do int and followed by a inside parentheses, it converts a, which is a string, to a number. And we can inspect the type over here, and it says int. So apply int on a string, and it gives back to you an integer. What if this is character? What if this is MDS? And then if we do this, and a, it says value error, invalid literal for int. Okay, it doesn't understand how to convert MDS to a number. Okay, so it has to be a convertible type. So basically, this is how we do conversions. So we have functions in order to do this. We have int, we have float to convert a number to or a string to a float. We also have stir in order to convert a number to a string. And what else do we have? Yeah, that's about it.
It doesn't take word-based like 36. If I write that in Word, throw it into int, it's still going to fail?
No. What do you mean by word?
So if I literally type 36, THIRTY dash.
Oh, yeah. So the question is if we, instead of a number like the digits, if we supply the worded version of that, so we say 36 THIR something. No, it's not going to work, so we can try that. If it works, it will be a super weird thing. Yeah, okay, yeah, thankfully it doesn't work because it would lead to a lot of weird problems. Okay, so integer this works quite nicely. We can also turn this directly into a float, and you can see the decimal point appearing over here. You can also do the reverse. You can have a number like this, and then you can apply, suppose that we want to, yeah, I'll get to the application, but for now, this is returned as a string, and how do we know that? Because it's surrounded by brackets. Okay. So that's about it for the string type. Now questions.
Is there a permanent function that permanently reassigns it, or do you just like reassign like a equals int a? Obviously if you call int a just for that equation, it'll be int, but then if you call a again, it'll go back to being whatever it was. Is there a more elegant way to do it than a equals int a, or is there a one function way to do that, or you just reassign it?
Yeah, that's the only way I know. Yeah, just to reassign it. So yeah, you say that take the integer value of that and then reassign it back to the variable a, and yeah, that will be stored there. Any other? Yeah. Okay, yeah, good question. Does it matter if we use single quotes or double quotes? So in general, no. But there are some situations, for example, we'll get to that in a bit. There are situations that you actually have a double quote inside of your string. And if you use double quotes on the both beginning and end of the string and a double quote in the middle, that messes things up. So in that instance, we have to use either a single quote for the entire string and double quotes in the middle, or the reverse. Okay. All right, so now let's talk about an interesting data type, probably one of the ones that's used a lot in Python, lists. Okay, so a list is basically a collection of values. And I'm avoiding saying objects at this point, but we will learn what objects are in lecture 3. It's a collection of values that's ordered, basically. Okay, so an ordered collection of objects. And the way that we define lists is that, so let's say list 1, is that we type square brackets, and then we have the values that we want to have in there. So 1, 2, 3. Okay, and one important thing is that we are not limited to just numerical values, of course. So we can have list 2, and then we can have A, and then B, and something like that. We can also have a combination of these. So we can have something like that, and that's perfectly valid. Sorry, I forgot to put list 1. Okay, yeah. And okay, so a list can hold an order, is an ordered array of objects. So basically, lists can hold any type of value that we have learned so far. So strings, integers, floats, and everything. They can even store like functions. They can store other lists. Basically, everything that you can think of inside of Python. They can store anything that you like. Okay, and again, if we inspect the type of a list, we'll get back the type as a list. So it's its own data type inside of Python. Again, with this data that I have here, with this variable, there is the data that I'm storing, and there's also the kind of operations that I'm allowed to do on that data. But more on that later. Okay, one important thing about lists is how we retrieve values from lists. So for example, if I want to retrieve my name from this list, how can I do that? So let me clear this up over here. Okay, so the way that we do this is by indexing. Because the list is ordered, we can type list1, and then inside of square brackets, we can supply an index. And indexes in Python, basically the number of things, always starts from 0. That's very important. So the first element is stored in index 0. If I type that, I get back 1. If I want to get back this string over here, 0, 1, 2, 3. Okay? That's element number 3. Okay, and I'm going to tell you a shortcut for obtaining the last element of a list. That's by doing -1. That's the last one, second to last, and so on and so forth. Okay? And also, there's another indexing technique used for lists and for arrays and for basically every kind of ordered list. That's by picking out a slice of that list. For example, if I want elements number 3 and number 4 here, basically, I have to do something like this. So let's count 0, 1, 2. So I want everything from 2 all the way up to 3. Okay? And if I do that, interestingly enough, I don't get back the last element. This is because indexing slicing only works up to a particular index, not including the index itself. So if we do something like this, although index number 4 doesn't exist in the list, but we have to count up to 4 in order to be able to retrieve those items. Again, there's a shortcut for slicing. If you want to take, for example, anything from number 3 all the way up to the end of the list, let's suppose that we have other items here, for example, UBC, something like that. If I want to pick anything from 3 onwards, I'll do this. Just omit this number over there, 2, colon, and then this picks everything. Okay? And the same thing works if you want to pick everything from the first element up to a certain index. So 0, 1, 2, 3. What should I type here? I want to pick everything up to this string armon. Should I type 3? No, because it counts up to a number, not including that particular index. Okay, so that's about slicing. And now let's talk a bit about list methods. Okay, so what is the meaning of methods? Again, going back to what we discussed in the beginning of the lecture. So associated with certain data types, with all data types basically, are certain operations. Okay, so for example, for a list, you are able to clear the list. Okay, just empty it entirely. Okay, or remove an item from the end of the list, append an item to a list. These are the kind of operations that are defined for the list type. Are these the kind of operations that you can do with a number? No. Is this a kind of operation that you can do with a string? No. Okay, this is specific to lists. Let's now learn about those kind of operations. And in the world of Python, and in more general terms, in object-oriented programming, as we will learn in Lecture 3, these operations, these particular functionalities are called methods. So when we say list methods, this is to mean the kind of functions that are available to us in order to do some certain things on a list. Let's learn what kind of operations are available. So if you type list1 dot, you're going to see a list of basically functions, or as we call them, methods. Okay, so let's learn a bit about these different methods, just to show you a couple of examples. So the first method is append. And this is, as you can see, open close parentheses. This means that this is a function. So basically what it does is that it appends or adds an item to the end of a list. Let's suppose that I want to add, another number. Okay, this weird number, okay? And when I inspect list 1 again, you can see that that number is appended to the end of the list, okay? And then there are also other kinds of operations that you can do. For example, if we have a numerical list over here, we can do something like this. Stir list 1. Oh, I forgot to run that again. Okay, list 1. And now we see, so this was basically sorted from the beginning. So let me do this number over here and then sort. And then this sorts the values inside the list. So these are just two examples of the kind of operations that we can do. Again, let's do another operations. Let's do clear, okay? And then let's inspect the value afterwards. When you do clear, it gives back to you an empty list, okay? And there are several different types of operations that you can just have fun with in your free time. You can find a full list of them here. So append, clear, copy, count, extend. We won't go through all of that, but in the lab, we will discuss a number of them and go through examples of them so that you get more familiar with them. Again, there are detailed examples in the lecture notes that I'm going to post in the afternoon today. Okay, another data type, and I guess that will be the last one that we'll introduce today, is the set data type. Okay, and a set is a lot like a list, except for that it's not ordered, and it doesn't tolerate duplicates, because it's like in mathematical terms, it's a set. A set cannot contain duplicate values. And I'm just going to very quickly give you an example of sets. For example, if we define a set, and in order to define a set, let's say set 1, there is no like brackets or anything that define them. We have to use open and close parentheses. So for example, let's define this set to be two, and 3, and 5, and 5, and 100. Okay, and now let's inspect set 1. And you can see that although I had 2 2s and 2 5s in here, what I get back from the set is a set of just 2, 3, 5, and 100. And note that if I want to get back like this item, let's say this one over here, I can't do set 1 in brackets and give it an index, because it says the set object is not subscriptable, meaning that we can't index into a set. Okay, and a method associated with a set is the add method, and it's not called append. Do you know why?
Because it's not going to the end. It's going to
Exactly. Because it's not ordered, so appending means adding something to the end of something else, and there is no end. So we use add, and suppose that I add again my name and set 1. Okay, there we go. All right, and this is the notion of a set. We'll use sets much more often in 512 in algorithms and data structures, but for now, just so you know what they do, they don't preserve order, and then they don't tolerate duplicates. That's it, yeah.
If you were to apply an operation like sort to a set, would it convert then to a list?
No, I don't even think that sort is defined for sets. So there's no sort. Yeah. Okay, but basically you can convert between the types. So let me try that. So if we do list,
Oh, you can just make it a list.
yeah, you can convert it like type conversion. Okay. Pardon me, can you repeat your question? Oh, I don't think that's needed. You just... Oh, okay, yeah. So this is because of the first argument are the values that you want to supply to the set, so you have to use double parentheses. But we will get to these particular ways of supplying basically arguments to functions. So this is this particular way that Python developers have decided to implement this function. There's no particular reason for that. The basic reason is that probably there are other arguments that you can supply with this, so in order to not mix it with other arguments, use parentheses. Okay, so now let's also talk a little bit about different string methods. Again, these are operations that are defined for strings. Okay, let me clear that up. Code, define a string, let's say name and, or no, just stir1. Okay, and let's say DSCI 511 is fun. I hope it is. Okay, so if I type stir1 and then dots, the dots is the way that we access the operations that we can do for a particular data type, and you can see that a bunch of operations just shows up, right? And let me just show you an example of one operation that you can do, split. Okay, inside of split, I can provide a character that I want my string to be split on. Okay, for example, if I type space, then it will give back to me a list of the words inside of this string. It basically splits on the spaces. So you can see that here I have a list, and the list contains these words, which is split using these space characters. Okay, this is just one method. Another method that you might want to use is something like this. Let me open up a Chrome, stir1, and then let's say upper. Okay, and this converts everything to uppercase. Okay, so this is, again, we have the string type, we have some certain operations that are available to us for the string type, and that constitutes the data type notion, or the concept of a data type. Again, these are the type of operations we'll use a lot in Lab 1, and we have, there are detailed examples in the lecture notes. You can go through them, you can inspect different types of methods for these, for the string type. And again, one thing that, one particular, let's say, skill that you have to develop in your career is to look up and read documentation. That's like super, super important. There's not always somebody to tell you what to do. There are some packages that simply there's no tutorial for, but there is usually, almost always, there is a documentation for that. So whenever you're not sure about something, for example, you want to see what kind of methods are available for strings, just Google it. Python, documentation, stir. And then look up the different methods and examples and everything inside of that. And it's in the beginning, it's kind of, the documentation might look like cryptic and very hard to understand. But little by little, you're gonna develop that skill to quickly find the kind of information that you need. And probably a meta skill, I would say, is to be able to quickly find what you need. So that's very important. I don't memorize most of this stuff, but I know where to look for them if I need them. That's the skill that will help you probably more than anything else. Okay, so I know it's somewhere in the documentation. If I want to just Google that and go there and read about it. Okay. Now, about strings, let me show you a couple of examples about how we can work with the string type. One thing that's available to us with strings is the addition operator. For example, if I do, let me do this. So stir2, and then here I say DSCI is fun, and then let me do this, stir1 plus stir2. Okay, this might not mean anything at first, but this is an operation, again, that's defined for two strings in Python. It is well defined. Python knows how to handle this. And when we do this, it will give us a concatenation of the two strings. And you can see that we're missing a space here, so I can, for example, add the space here, and then it concatenates the strings. And same goes for lists, actually. So if we have like a list here, 1, 2, 3, and I have another list over here, I can add them together using this plus operator. Okay, and you can see here, as a result of this addition, we have this overall list over here. Okay, so just for you to, so that you've heard, this is called overloading an operator. It means that the operator has some certain functionality like in mathematics, but here we overload that with additional operations for certain data types. Okay, one other thing about strings is the concept of string formatting. So, yes, question? What operation? I'm not sure, but you can try that out. Yeah. Okay, so one thing that we might want to use is to basically embed like a number inside of a string. So suppose that we have a number here, let's say, I don't know, something like that, okay? And we want to have a string inside of which we put this number, but we want it to be formatted in a particular way. The way that we do this is that instead of just saying, let's say, the number is something like that, and then type num, which says something like that, we can actually embed this number inside of the string. And that's by enclosing the variable name inside of curly braces, and then the variable name, and then after a colon, we can specify a format for our number, okay? And here I have a decimal number. I want to show it as a decimal, so I type dot, and then I can specify how many digits I want to have after my number. For example, I want 3, and then I specify that this is a floating point number, okay? If I do that, it doesn't say anything. It just prints num colon, literally. This is because I have to tell Python this is a formatted string by prepending an F to the beginning of it. Okay, and there we go. This is how we format strings, and then there are a couple of examples in the lecture notes that tells you how to manipulate this formatting string over here so that to get the result that you like. Okay, so in the next 3 to 4 minutes, I'm just gonna quickly talk about conditionals. So let me just pull up the lecture notes. Okay, and when after 9:20, so we have 2-3 minutes, we have to leave the room. I guess there's another lecture coming up in 9:30 or so. So we have to leave the room almost immediately. So let me just go through conditionals. I've talked through most of this stuff that we can see over here. Whatever is left here, like we have to talk about dictionaries, but again, that's 2 to 3 minutes. I'll talk about that in the lab. Let me just quickly show you conditionals. So the way that we can conditionally run code is by if-else statements. And I've already shown you like conditionals, how we can check whether two numbers are equal, whether two statements are equal, or something is bigger than the other. So we have the if condition, the if keyword, followed by a condition, and then followed by a colon. And then the most important thing here is that we have to indent our code. So in Python, we have to indent the code in order to say that this block of code belongs to this particular statement. So with an if condition, we have to have this indent. Otherwise, this part of the code does not belong to the if statement. That's the most important thing. Otherwise, it's pretty basic stuff. If a condition is true, then Python executes what's underneath that if statement. Else, if another condition is true, it does something else. And finally, if none of those conditions or Booleans evaluate to false, then a final condition will be executed. Okay, so the rest of it is not, we are pretty much done with this lecture. The rest of it is just details that you can go through. If you have any questions, please feel free to message me on Slack or ask me during the labs. But we'll go over different examples through the lab